single shaft of sunlight cuts perfectly between ancient stones at Stonehenge. That moment is not magic, it is a message. It is part of a hidden language written in stone and sky, a language we are only now beginning to understand. We are unraveling the scientific principles embedded in monumental alignments. From the pyramids to the temples of Angkor Wat, these structures hold encoded secrets of astronomy, mathematics, and a forgotten understanding of the Earth itself. By the end of this journey, you will see history's greatest monuments not as silent ruins, but as sophisticated scientific instruments. Why would a civilization spend generations aligning a temple with a single star? What profound knowledge was considered so vital it had to be built into the landscape itself? What do you believe is humanity's greatest legacy carved in stone? That message in stone and sky is written in a very specific language. We call this language monumental alignment. Sounds technical, but the idea is beautifully simple. A monumental alignment is the deliberate, precise orientation of a massive human structure toward something of immense importance in the natural world. This could be the point on the horizon where the sun rises on the longest day of the year. It could be the position where a particular star first appears at dusk after being hidden for months. Sometimes, it is an alignment with a distant, sacred mountain or a solitary standing stone miles away. These are not random placements. They are intentional choices, frozen in architecture, that connect the human world directly to the cycles of the cosmos or the features of the Earth. This practice is not confined to one time or place. We see it in the vast desert lines of oriented toward water sources and celestial events. We find it in the grand temples of ancient Egypt, where corridors point to stars associated with eternal life. It appears in the long burial mounds of Neolithic Europe, where entrance passages capture the low winter sun. The scope is truly global, and that is our first clue that we are dealing with something fundamental, a thread of human thought woven across continents. But with so many ancient sites, how do we separate genuine intention from mere coincidence? After all, if you build enough structures, some will accidentally line up with something. This is where science steps in to help history speak. Researchers do not rely on a single alignment at one site. They look for patterns. If a culture builds dozens of temples and a statistically overwhelming number of them face the summer solstice sunrise, that pattern points to a rule, not luck. They also look for cultural context. If the myths and texts of that society speak of a sun god being reborn at the winter solstice, and their most sacred tomb is aligned to that exact sunrise, the alignment transforms from an architectural fact into a profound statement of belief. It becomes a bridge between their cosmology and their calendar, built in stone. This shift from vague wonder to focused, evidence-based inquiry is the foundation of our entire investigation. To read this language, we first had to learn its alphabet, and that required a new way of seeing the past. This detective work has a name: archaeoastronomy. Think of it not as a dusty academic term, but as a powerful decoding tool. It is the fusion of two great disciplines, archaeology and astronomy, brought together to answer a single, profound question. How did ancient cultures perceive the cosmos, and how did that perception shape their world? And arrives at a site with a toolkit far beyond a simple compass. They use precise instruments to measure the exact orientation, or azimuth, of a doorway or a corridor. They employ sophisticated software to roll back the clock, reconstructing the night sky as it would have appeared thousands of years ago. This allows them to calculate the precise rising point of a star or the sun on a specific date in the deep past. But the true genius of the field lies in its next step. A line of stones pointing to a star is just geometry. To understand its meaning, you must consult the culture's own stories. This is where ethno-historical records become invaluable. If the local mythology speaks of a hero who ascended to become the morning star, and the temple's main axis points directly to where that star first appears, the alignment transforms. It is no longer just an observation. It becomes a narrative in architecture, a way to enact a sacred story in real time, year after year. This rigorous, evidence-based approach championed by researchers like Clive, turns speculation into science. It demands that any proposed alignment must be statistically significant, and crucially, it must make sense within the worldview of the people who built it. With this powerful tool now in our hands, we are ready to decode the first and most universal chapter in this ancient language, written by the sun itself. The sun was the first and most reliable clock humanity ever knew. Its daily arc and shifting horizon points offered a perfect, visible rhythm to structure a year. For societies whose survival depended on planting and harvest, tracking this solar cycle was not a matter of philosophy, it was a matter of life. This necessity gave rise to the second fundamental principle in our investigation, solar alignments. These are monuments that function as calendars in stone. The most powerful solar markers target the 4 pivotal days of the year, the solstices and equinoxes. The summer solstice marks the sun's northernmost rise, the longest day. The winter solstice is its southernmost, the shortest day. The equinoxes, halfway between, are when day and night are of equal length. To pinpoint these days with stone, you need extraordinary precision. In Ireland, a 5,000-year-old passage tomb holds one of the most breathtaking examples. Above its entrance is a narrow opening called a roof box. For just a few days around the winter solstice, and for only about 17 minutes at dawn, a single beam of sunlight pierces through this roof box, travels down the 60-foot-long passage, and floods the central chamber with golden light. This event is not a happy accident. It required generations of sky watchers to note the sun's slow crawl along the horizon, and then master builders to translate that observation into architecture with inch-perfect accuracy. That beam of light was a message. In the depth of winter, it proclaimed the sun's rebirth and the inevitable return of spring. It was a communal promise, carved into the landscape, that the cold would end and the earth would grow again. This deep empirical understanding of the solar cycle, encoded from Stonehenge to the temples of the Maya, shows us that these monuments were active scientific instruments. They were observatories that measured time, and their alignments were the literal hands of a celestial clock. But the sun was not the only timekeeper in the ancient sky. A more subtle, yet profoundly significant dance was also being watched and recorded, one that required even greater patience to understand. The moon presented a far more complex puzzle than the sun. Its rhythm is not a simple annual cycle, but a long, slow dance that unfolds over nearly 2 decades. While the sun reliably marks the seasons, the moon's rising and setting points on the horizon shift dramatically. They do not simply swing back and forth like a pendulum. Instead, they reach a northernmost extreme, pause, and then over the course of 18.6 years, they migrate to a southernmost extreme before slowly returning. This entire, majestic cycle is known as the lunar standstill. To track it, to even notice it, requires a civilization to think not in seasons, but in generations. It demands a continuity of observation that stretches far beyond a single lifetime. This brings us to the third profound principle, lunar alignments and the long-term cycle. When we find a monument that seems to target the moon's most extreme rising point, we are looking at evidence of a staggering investment in observational science. Consider the temple complex on the island of Malta, built over 5,000 years ago. At the equinoxes, sunlight illuminates specific carved stones, but some researchers propose that its smaller apertures and alignments may also frame the extreme southerly moonrise of the major lunar standstill. This is not a calendar for planting crops. This is a generational clock, a piece of architecture designed to capture a celestial event that only repeats once in a human generation. Why would a society commit such immense resources to tracking this slow lunar wobble? Anthropologist offers a compelling insight. This deep knowledge was likely tied to ritual calendars of great importance, and perhaps even to the prediction of eclipses. In the ancient world, an eclipse was a moment of profound cosmic drama where the predictable order of the heavens seemed to break. The ability to foresee such an event, or to demonstrate that your sacred temple was aligned with the very cycles that governed it, would blend scientific understanding with immense social and spiritual authority. It transformed celestial mechanics into a source of cultural power. This knowledge of the sky did not stay abstract. It was physically anchored, mapped onto the Earth itself, creating a sacred geography where every mountain, river, and stone could tell a story written in the stars. The ground beneath our feet holds its own geometry, a hidden map written not in ink, but in landscape. This brings us to the fourth, and perhaps most physically rooted principle, geodetic alignments, the art of mapping the Earth's form. Beyond tracking celestial bodies, some ancient builders demonstrated a profound awareness of the Earth itself, connecting monuments across vast distances and aligning them with the planet's invisible grid. While popular ideas of mystical energy lines, or lines, remain in the realm of speculation, more tangible evidence points to a deliberate understanding of terrestrial geometry. Consider the Great Pyramid of Giza. Its base is aligned to the cardinal directions, north, south, east, and west, with an accuracy that still astonishes engineers today. Its northern face points almost perfectly to true north, with an error of less than 1/15 of a single degree. Achieving this 5,000 years ago, without modern instruments, implies a sophisticated method for determining direction, likely involving careful, long-term observations of a circumpolar star's transit across the meridian. This was not just building a tomb, it was anchoring a structure to the very axis of the world. This sense of a planned, large-scale geography extends beyond single sites. Researchers have noted that several major pyramids in Egypt appear to be arranged along specific meridians, or lines of longitude, suggesting a coordinated master plan across the landscape. But the integration of monument and environment reaches its most expressive form in places like the plains of Peru. Here, those immense lines and shapes etched into the desert, only make sense from an elevated perspective. Their alignments are not to the stars above, but to the horizon and the surrounding foothills. Certain lines point directly to the point on the horizon where the sun rises during the winter solstice, while others seem to channel toward distant sources of water, the most precious resource in that arid land. The lines become a ritual map, connecting the people to the cyclical gifts of sun and water, and integrating their ceremonial space with the permanent features of their world. Similarly, the thousands of standing stones at Carnac in France are not placed randomly. Their grand avenues run parallel to the local coastline and seem oriented towards significant horizon notches where celestial bodies would rise. The monument was not dropped onto the land, it was designed with the land, using the natural topography as a frame for celestial events. This deep, intentional relationship between a structure and its specific location forces us to ask a pivotal question. Why this hill, this valley, this particular bend in the river? The answer moves us from pure astronomy and geometry into the realm of human meaning, into the stories and beliefs that made a place sacred long before the first stone was ever set. The stone itself may have been chosen for more than its shape or durability. This leads us to a fifth, deeply intriguing principle: geomantic and geophysical considerations. For ancient builders, the choice of location was a sacred act, a decision that wove together the visible landscape with forces they believed flowed invisibly beneath it. Many of the world's most revered monuments sit atop geological anomalies, places where the Earth itself behaves differently. These could be subtle variations in the local magnetic field, the presence of powerful underground water aquifers, or even the meeting points of seismic fault lines. While modern science often views these as mere geological facts, the builders may have perceived them as concentrations of vitality, as places where the spirit of the Earth was most accessible. The idea that ancient cultures could detect such subtle forces often centers on practices like dowsing, the use of a forked rod or pendulum to locate underground water. Whether this works through a heightened sensitivity to minute electromagnetic changes or through other means is still debated. Yet the persistent association of sacred sites with these features is difficult to ignore. Take Chartres Cathedral in France. Some researchers, like the work popularized by Louis, suggest its specific location was not random. They propose that the cathedral's builders, possibly informed by even earlier traditions, placed its crypt directly above a network of underground water channels. The constant, subtle movement of this water could, in theory, create a unique resonant field, potentially influencing the building's legendary acoustics and contributing to the palpable, serene atmosphere that visitors have reported for centuries. This is not about proving magic, but about recognizing a different kind of empiricism. If true, this represents a science far more holistic than our own. It viewed the Earth not as an inert rock, but as a living, breathing organism crisscrossed with channels of energy. Aligning a temple or a stone circle to these terrestrial currents would be as logical to them as aligning it to the sun. It was about harmonizing human creation with the perceived heartbeat of the planet. This profound desire for harmony did not stop with location. It extended upward into the very proportions of the structures they built, governed by a sacred language of number and form. This invisible architecture of harmony was built with a secret language of number and shape. We have arrived at the sixth principle, sacred geometry and proportional alignment. Beyond the physical orientation of a temple toward a star, its very dimensions could be a map of the heavens. This is the idea that certain mathematical ratios and geometric forms hold a profound, even cosmic significance, and that by building with them, you are literally constructing a piece of the universe's order on Earth. The most famous of these is the golden ratio, often represented by the Greek letter phi. It is an irrational number, approximately 1.618, that appears repeatedly in nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. It was considered the formula for perfect, pleasing proportion, and it shows up with startling frequency in the world's most enduring monuments. The Great Pyramid of Giza presents a classic case. The ratio of its perimeter to its height is very nearly 2 pi. Furthermore, the slant height of its face divided by half its base length closely approximates phi, the golden ratio. Whether this was intentional or a byproduct of other design choices is a topic of endless debate. But the possibility remains tantalizing that the pyramid's builders encoded fundamental constants of mathematics into its very bones. This practice did not end with the ancient world. Centuries later, the master builders of Europe's Gothic cathedrals were deeply engaged in this same symbolic science. The floor plans of Chartres or Dame are not random. They are often based on perfect geometric figures, the square, the circle, the pentagon, and their intersections. These shapes were associated with the Platonic solids, forms that the philosopher Plato linked to the fundamental elements of creation, earth, air, fire, water, and the cosmos itself. By laying out a cathedral using these geometries, the architects were doing more than creating a stable structure. They were aligning the entire building with a philosophical and cosmic ideal. A rose window might be positioned at the intersection of specific geometric lines, making it not just a beautiful feature, but the symbolic heart of a mathematical diagram made manifest in stone and light. This is why we call it a language. A solstice alignment speaks of time. A lunar alignment speaks of generational cycles, but a proportional alignment speaks of essence. It says this building is not merely oriented toward the cosmos, it is constructed according to the same principles that govern the cosmos. The harmony is not just directional, it is embedded in every measurement, a resonance built into the walls themselves. But this raises a practical, almost miraculous question. How did they do it? Without laser levels or computer-aided design, how did ancient surveyors and masons translate these perfect celestial and geometric ideals into ton blocks of stone? Often across miles of rugged terrain, the tools were astonishingly simple, yet the results stand as a testament to human ingenuity. This seventh principle reveals the technology of alignment, where profound scientific understanding was built not with computers, but with sticks, strings, and shadows. The question is not what they used, but how they used it. Consider the Egyptian Merkit. It was essentially a forked stick with a plumb line. By sighting along the line toward a specific star, an observer could track its transit across the night sky. With patience, they could determine true north by finding the precise midpoint of a star's arc. The Roman was a cross of wood with weighted cords hanging from each arm. Planted in the ground, it allowed surveyors to sight perfectly straight lines and right angles across the landscape, laying out the foundations of cities and roads with military precision. The true genius, however, lay in the methodology. The tool was just the beginning. The real work was in the observation. To capture the solstice sunrise, you do not need a telescope. You need a fixed observation point, a distant horizon marker, and years of careful watching. You place a stone, and you watch where the sun rises on the longest day. The next year, you place another stone to mark that exact spot. Over generations, this practice becomes refined. You might create a long avenue of posts that frames the rising sun, or carve a narrow slit in a rock that allows a single beam to strike a target only on that one day. Researcher Alexander studied hundreds of stone circles across Britain and proposed that their builders used a system of geometry based on a standardized unit of measurement, a megalithic yard, and a deep understanding of Pythagorean triangles centuries before Pythagoras. They could have created perfect right angles for their monuments using nothing more than a long, knotted rope. By marking off lengths of 3, 4, and 5 units, they could form a triangle with a perfectly square corner. This rope became a portable, powerful surveying instrument. What this tells us is that precision is not solely a product of advanced technology. It is a product of advanced thought. It is the result of a culture that values meticulous observation, that records its findings, and that passes that knowledge down through generations in a practical, usable form. The monument is the final, frozen proof of a long chain of patient discovery. To see this principle in its most complete and mysterious form, we must travel to a windswept plateau in Peru, where the lines drawn on the earth are so vast they can only be understood from the sky. Stonehenge stands as the ultimate riddle written in stone and sky. Its massive lintels and sarsen circle are not just a monument, they are a layered celestial blueprint. The primary alignment is majestic in its simplicity. The central axis points directly to the summer solstice sunrise in one direction and to the winter solstice sunset in the opposite. On those pivotal days, the sun appears to rise and set in perfect harmony with the architecture, a spectacle that draws thousands to witness its ancient precision. But this is only the first sentence of a much longer story. The true genius of Stonehenge lies in its subtler features. Scattered around the main circle are 4 so-called station stones. Their positions, along with the ring of 56 holes just inside the earthwork bank, may hold a key to a far more complex astronomical function. Some researchers, like Hawkins, who pioneered early computer analysis of the site in the 1960s, proposed these features could track the moon's complex 18.6-year cycle and even predict eclipses through the 56-year Saros cycle. The idea of Stonehenge as a Neolithic computer captured the public imagination, and while the term is an oversimplification, it powerfully underscores a vital truth. This was not merely a temple aligned to the sun, it was a sophisticated observatory designed to calculate celestial events. The famous heel stone, standing solitary outside the circle, plays a crucial dramatic role. At dawn on the summer solstice, when viewed from the center of the circle, the rising sun appears to crown the top of this stone, framed perfectly by the great arches. This was theater on a cosmic scale, a moment where architecture, landscape, and heaven conspired to create a shared experience of awe. Building this required knowledge accumulated over centuries. Stonehenge was a generational project, with its construction phases spanning over 1,500 years. Each generation added to and refined a master plan, physically cementing their hard-won astronomical understanding into the Wiltshire Plain. It served the profoundly practical need to mark the seasons for agriculture and gatherings, but it also fulfilled a deeper, ritual purpose. It connected the community to the rhythms of the cosmos, affirming their place within a larger, ordered universe. This blend of precise science and profound meaning is what makes Stonehenge the archetype. And this same intricate dance of alignment, where every stone is a word in a celestial sentence, finds a powerful echo far to the south, under the relentless sun of the Egyptian desert. While Stonehenge is a circle open to the sky, the pyramids are a geometry of perfect closure. On the Giza plateau, alignment becomes an act of absolute precision. The sides of the Great Pyramid are oriented to the 4 cardinal directions with an accuracy that still defies easy explanation. The north face points to true north with an error of less than 3/8 of a degree. To put that in perspective, that is less than 1/15 of a single degree, a deviation so tiny it is the equivalent of aiming a laser pointer at a target a mile away and missing its center by less than the width of a human hand. How did they achieve this? The most plausible theory involves the circumpolar stars, those stars that never set, rotating around the north celestial pole. By tracking the movements of a pair of these stars over many nights, ancient surveyors could have bisected their arcs to locate a fixed, invisible point in the sky, true north, and then transpose that line onto the desert floor with ropes and markers. This was not just building, it was celestial cartography, anchoring a mountain of stone to the axis of the world itself. But the alignments at Giza reach far beyond the horizon. Deep within the Great Pyramid, narrow shafts, often called air shafts, angle upward from the king's and queen's chambers. For a long time, their purpose was a mystery. We now know they are not random ventilation ducts. One pair of these shafts is aligned with extraordinary care. The southern shaft from the king's chamber points directly toward the star Al, the star in Orion's belt. The northern shaft targets the pole star of that era. Similarly, a shaft from the queen's chamber aimed toward Sirius, the star in the night sky. In Egyptian cosmology, these were not just points of light. Orion was associated with Osiris, the god of rebirth and the afterlife. Sirius, whose heliacal rising just before dawn marked the annual flooding of the Nile, was linked to Isis, the goddess of life and magic. These shafts were not for air, they were spiritual conduits. They were built so the soul of the entombed pharaoh could ascend directly to the imperishable stars, to join the gods in an eternal cycle. The architecture itself was for a celestial journey. This connection between earth and sky becomes even more grand when you step back and view the entire Giza complex from above. The arrangement of the 3 main pyramids, Khufu, and has long intrigued observers. In the 1990s, author Robert proposed a compelling, though hotly debated, idea known as the Orion correlation theory. He suggested that the spatial layout of these 3 pyramids mirrors the 3 stars of Orion's belt, and that the nearby Nile River corresponds to the Milky Way in the celestial map. The fit is not perfect, and many Egyptologists argue the correlation could be coincidental, or that the pyramid placements were dictated by geology, lineage, and other practical factors. Yet, whether by precise design or inspired symbolism, the idea captures an essential truth about the ancient Egyptian mind. For them, the cosmos was a mirrored reality. The world below was a reflection of the world above. By building a sacred landscape that echoed the heavens, they were performing the ultimate act of cosmic harmony, ensuring the order of the universe, was maintained. Their monuments were not just tombs, they were permanent anchors stitching the fabric of the sky to the bedrock of the earth. This profound desire to mirror the heavens in architecture did not fade with the ancient world. It simply found new expression in the dense jungles of another continent, where temples were built to capture not just stars, but the very breath of time. The avenue of the dead cuts through the ancient city with a purpose you can feel in your bones. This colossal central axis, however, does not point to true north. Instead, it is deliberately skewed 15.5 degrees east of north, a choice that transforms the entire city from a simple urban plan into a complex cosmic instrument. This precise angle was no accident of ancient surveying. It was a deliberate alignment with the celestial sphere. On a specific, significant evening each year, the Pleiades star cluster, known to cultures across the world, would set directly along this line, sinking into the horizon as if descending the avenue itself. But the alignment held a second, equally vital secret. A line perpendicular to the avenue, running east-west, pointed to the sunrise and sunset on the days when the sun passed directly through the zenith, the point directly overhead. In the latitude of this zenith passage happens twice a year, and it was a cornerstone of the calendar. On these days, vertical objects cast no shadow at noon, a moment of profound symbolic power signaling the sun's perfect union with the earth. This alignment tied the city's very grid to the solar cycle that dictated planting and harvest. The monumental architecture then anchored this celestial map to the terrestrial world. The Pyramid of the Sun and the Pyramid of the Moon were not placed arbitrarily. Their positions and imposing forms were carefully calculated to mirror the profiles of the sacred mountains that cradle the valley, creating a symbolic landscape where the built environment echoed the natural one. Every citizen walking the Avenue of the Dead was therefore moving through a model of the universe, a place where the rhythms of the stars, the sun, and the earth were literally built into the streets. This fusion of astronomy, geography, and urban planning was the ultimate cosmological statement. It declared that the order of the city, and by extension the power of its unseen rulers, was not a human invention, but a direct reflection of the immutable cosmic order. Their authority was written in the angles of the avenues and the alignment of the pyramids, making their rule seem as natural and inevitable as the setting of the Pleiades. This pattern of weaving multiple systems into a single, grand design is not unique too. It is a signature of a deeper, global understanding, one that saw no separation between the science of the sky and the art of building a civilization. A powerful pattern emerges when we look at the world map of ancient monuments. Separated by vast oceans and thousands of years, cultures that could never have known of each other's existence arrived at remarkably similar solutions. The Maya of and the pyramid builders of Egypt, for instance, both developed astonishingly precise solar calendars and encoded that knowledge into the steep slopes of their pyramids. On another continent, the sun temples of ancient Mesopotamia and the lonely stone circles scattered across Britain share an identical, unwavering focus on the solstices. This is not evidence of a lost global civilization or secret contact across the seas. Instead, it points to something even more profound, a convergent cultural evolution of science. When faced with the same fundamental problems, how do we mark time? How do we predict the seasons? How do we understand our place in the cosmos? Human minds independently arrived at similar architectural answers. Anthropologist John B. observed a critical catalyst for this phenomenon. As a society grows more complex, with organized agriculture, systems of taxation, and scheduled rituals, the need for a reliable, precise calendar becomes urgent. This practical necessity drives the meticulous, long-term observation of the heavens. Once that celestial knowledge is acquired, it naturally seeks expression in the most permanent medium available, stone. The alignment becomes the physical manifestation of a society's highest intellectual achievement, its hard-won understanding of universal order. This global pattern tells us that the drive to align our greatest structures with the cosmos is not a quirky historical footnote. It is a fundamental chapter in the story of human intellectual development, a recurring signpost on the path to civilization itself. Yet for every genuine alignment that whispers of ancient genius, there is a proposed alignment that shouts of modern imagination. The line between profound discovery and persuasive coincidence is notoriously thin, and our journey would be incomplete without acknowledging the shadows that surround this field of study. The human mind is a magnificent pattern recognition engine, but that very strength can become a trap. This brings us to a critical and necessary step in our unraveling, the need for rigorous skepticism. With thousands of ancient sites scattered across the globe, simple statistics dictate that some will, purely by chance, line up with a star or a solstice sunrise. The real challenge, therefore, is not finding an alignment, but determining whether it was intentional. This is where the scientific method must act as our guide, separating profound insight from compelling coincidence. The key lies in two pillars: statistical significance and cultural context. An alignment must be so precise and so repeated across multiple structures from the same culture that the odds of it happening randomly become vanishingly small. But even a perfect statistical match is not enough on its own. It must make sense within the world of the people who built it. Does the aligned star appear in their mythology? Do their texts or art mention the solstice? If an ancient culture left no record of caring about a particular celestial event, then an alignment to that event, no matter how geometrically perfect, remains an intriguing possibility, not a proven fact. This discipline protects us from a common cognitive illusion known as pareidolia, the tendency to see familiar shapes in random patterns. The famous face on Mars, which turned out to be a trick of light and shadow on a mountain, is a perfect modern lesson. In our field, it is the risk of seeing a complex astronomical observatory in what might have been a ceremonial space with only a general solar orientation. Scholars like archaeologists have long urged this evidence-based approach, cautioning against the temptation to force archaeological data to fit a romantic, preconceived theory. This rigorous skepticism is not cynicism. It is the very heart of responsible discovery. It ensures that the genuine wonders we do uncover, the true messages carved in stone, stand on a foundation of credibility that cannot be easily dismissed. It clears away the noise so we can hear the real signal. And one of the clearest, most undeniable signals left by these ancient builders is not just in the direction they pointed, but in the precise mathematics they used to build. The stones themselves hold a hidden language of numbers. This is the eighth principle, mathematical encoding, where a monument's true purpose moves far beyond simple orientation. The physical alignment toward a star or solstice is only the first, most visible layer. Beneath that lies a deeper structure, a precise numerical code built into the very fabric of the building. These numbers were not arbitrary. They were the fundamental constants of a culture's universe, the sacred mathematics of time and space, made permanent in stone. The Pyramid of El-At offers a stunning example of this dual purpose. Its famous serpent shadow, which appears to slither down the staircase at the equinoxes, is a masterful piece of solar theater. But the structure itself is a mathematical treatise. The pyramid has 4 sides, each with 91 steps. When you add the single step at the top platform, you get 365, the exact number of days in the solar year. This was not a decorative choice. It was a deliberate encoding, turning the act of climbing the pyramid into a symbolic journey through the entire annual cycle. The monument was both a calendar and a cosmological model, its form teaching the rhythm of the seasons to anyone who understood its design. This practice of embedding sacred numbers into architecture was a global phenomenon. Across the ocean, the builders of the Parthenon in Athens pursued a different kind of mathematical perfection. Its dimensions are not random measurements. They embody the golden ratio, a proportion the Greeks called phi, which they believed represented ultimate beauty and harmony in the universe. The relationship between the length and width of the temple, the spacing of its columns, even the curves of its steps, were all calculated according to these ideal geometric principles. For the Greeks, this was not merely aesthetics, it was philosophy made visible. By walking through a space built with these ratios, a person was literally experiencing the mathematical order that they believed underpinned all of creation. This transforms a static building into a dynamic repository of knowledge. It becomes a stone textbook, a 3-dimensional archive. This suggests the alignment we see was likely part of a much larger educational or initiatory system. For an apprentice priest, a scholar, or a member of the ruling class, understanding the monument was a test of knowledge. You had to learn to read the language of its proportions, to see the calendar in its steps, to comprehend the cosmic harmony in its columns. The structure itself taught the core principles of mathematics, astronomy, and cosmology. But why go to such extraordinary lengths? Why encode this knowledge so permanently and so publicly? The answer is rooted in the most vital human concern: survival. A society that could accurately track the solar year could predict the rains and the floods, ensuring successful harvests. A culture that understood celestial cycles could maintain a ritual calendar that reinforced social cohesion and the authority of its leaders. The mathematical code was not an abstract intellectual game. It was the operating system for a functioning civilization. The monument, therefore, stood as both a library and a lighthouse. It preserved essential knowledge against the erosion of time, and it guided the community by aligning their lives with the immutable laws of the cosmos. This deep integration of number, stone, and sky represents the pinnacle of the ancient builder's art. But what happened when this meticulously crafted cosmic order was suddenly, violently disrupted? What did it mean when the predictable sun or moon vanished from the sky? The alignment of stone and sky required the alignment of an entire society. This is our ninth principle, the alignment as a technological system. Building a pyramid or raising a circle of sarsen stones was arguably the most complex project a pre-industrial civilization could undertake. It demanded far more than astronomical knowledge. It required a command of logistics, a managed workforce, a steady supply of food and materials, and a political structure capable of maintaining this effort across decades, even generations. The precision of the solstice alignment was the crowning achievement, but the true foundation was the organized human labor that made it possible. This transforms our understanding of the monument. It was not merely a celestial instrument. It was the central engine of a civilization's identity. By creating a shared, monumental goal, the ruling class could channel the energy of the community, foster a collective purpose, and solidify their own authority as the intermediaries between the people and the cosmos. The calendar encoded in the stones gave them a powerful tool. By accurately predicting the solstice or the heliacal rising of Sirius, they could announce the time to plant, to harvest, to hold a festival. This control over time was control over life itself. It demonstrated a privileged access to the divine order, making their rule appear not as a matter of force, but as a natural extension of cosmic law. The monument, therefore, served a brilliant dual purpose. For the farmer, it was a practical, communal calendar that ensured survival. For the priest-king, it was an immutable symbol of legitimacy, permanently etched into the landscape where no one could ignore it. This deep intertwining of practical science, political power, and spiritual belief explains the immense cost. The investment was not in stone alone, but in the very fabric of a cohesive society. Yet this raises a pivotal question that echoes down the centuries. How was this hard-won celestial knowledge, so vital to the state's function, preserved and passed on without the libraries and databases we rely on today? The answer lies not in books, but in a living, embodied tradition of ritual and memory. The true library of this ancient science was not made of parchment, but of people. In societies where written language was limited or entirely absent, the immense task of preserving complex astronomical data fell to a living, breathing system of memory. This brings us to the 10th principle, the role of oral tradition and initiation in preserving knowledge. Imagine the challenge of maintaining the precision needed to track an 18.6-year lunar cycle across 10 generations without a single written manual. The solution was a masterpiece of cultural engineering, a rigorous curriculum passed from teacher to student through spoken word, ritual, and physical experience. The monument itself became the ultimate teaching tool, a three-dimensional memory palace. An elder priest would not simply tell an apprentice about the winter solstice. He would lead them into the heart of the stone circle on the shortest day of the year. He would position them at a specific marker stone, have them watch the horizon, and witness the exact moment the sun's first sliver of light broke over the heel stone. That visceral experience, repeated year after year, etched the alignment into the initiate's mind with a clarity no scroll could match. The alignment was both the lesson and the proof. This method of transmission was incredibly accurate within a sustained cultural context, but it was also fragile. A single break in the chain, a war, a famine, a forced cultural change, and that meticulously preserved data could vanish in a generation, leaving behind only the silent stones whose purpose we now struggle to decode. This system reveals that the true scientists of the ancient world were often the priests, the shamans, the elders. They were the guardians of a secretive, applied knowledge that was both intensely practical and profoundly sacred. Their understanding of celestial cycles directly informed when to plant crops, when to move herds, when to hold the ceremonies that bound the community together. But this knowledge was not merely a list of dates. Its transmission was woven into a deep philosophical worldview. Learning the solstice alignment was not just memorizing an angle, it was understanding your people's place in the cosmic order, your relationship to the gods of the sky and earth. Initiation was about internalizing a reality where human time and celestial time were one and the same. This sacred stewardship of knowledge helps explain the monumental effort behind these sites. They were not just observatories, they were the permanent, immutable textbooks for this living tradition. They guaranteed that even if the words were forgotten, the lesson in stone and light would remain, waiting for a culture that could learn to read it again. And as we become that culture, using satellites and software to rediscover their alignments, we face a final, humbling mirror. What are the monumental alignments of our own civilization? And what will they say about us to the future? The silent stones were not just pointing at the cosmos, they were actively participating in it. This is the profound 11th principle, cosmology as the driving worldview. For the builders, these alignments were the physical expression of a living, breathing understanding of the universe, a map of reality where the heavens, the earth, and the unseen realms were all intimately connected. A temple aligned to a star was not merely an observatory. It was a conduit, a sacred axis, a pillar that linked the human world directly to the celestial one. In this animistic and holistic perspective, where everything possessed spirit and interconnection, the science of alignment served a higher spiritual geography. Its purpose was to make the invisible threads of the cosmos visible and permanent, to anchor the great cycles of creation into the very soil beneath their feet. This philosophical foundation transforms the immense labor from a practical project into a devotional act. They were not just moving stone, they were weaving their community into the fabric of the universe. With this sacred worldview in mind, sites that seem purely enigmatic begin to whisper their deeper purpose. Take the sprawling complex of Angkor Wat in Cambodia. From above, its majestic towers and vast moats reveal a stunning secret. The entire layout is a precise terrestrial model of the Hindu cosmos. The central towers represent the mythical mount, the axis of the world. The surrounding walls symbolize the mountain ranges at the edge of creation, and the immense moat mirrors the cosmic ocean. But the alignment goes deeper than symbolism. The western entrance gate is precisely aligned so that on the spring equinox, the sun rises directly over the central tower. This was not just a calendar marker. In the cosmology embodied by the temple, this event would have been seen as the sun ascending the world mountain, a moment of perfect harmony between the celestial order and its earthly mirror. The temple was not a building about the cosmos, it was the cosmos itself, built in stone. This same principle of sacred geography illuminates the mysterious Karnak stones in France. The thousands of menhirs arranged in long, parallel rows have baffled observers for centuries. But when viewed not as isolated monuments, but as part of a living landscape, a pattern emerges. These grand avenues run parallel to the local coastline, and many aligned toward distinct notches in the distant hills, precisely where the sun or moon would rise at key times of the year. The stones were not placed on the land arbitrarily. They were integrated with it, using the permanent features of the Earth as a giant natural sighting device. Walking between those rows was likely a ritual journey, a physical passage through a cosmological diagram where every step reinforced one's place within a structured, meaningful universe. This drive to manifest cosmology in the landscape reveals the ultimate goal of alignment. It was a technology of belonging, a method to banish chaos by proving, tangibly and undeniably, that human life was synchronized with the grand, orderly dance of the heavens. From the cosmic diagrams of Karnak, we descend to a vast, open canvas where the lines are drawn not with stone, but by removing the Earth itself. The lines of Peru stretch across nearly 400 square miles of arid plateau, a gallery of giant geometric shapes and animal figures so immense they can only be fully comprehended from the sky. This is alignment on a monumental, almost impossible scale, and its purpose remains one of history's most captivating enigmas. Unlike a pyramid that points upward, these ground drawings seem to speak to the horizon and the Earth below. For decades, researcher Maria dedicated her life to mapping and measuring these. Her meticulous work revealed a crucial first layer of their mystery. She found that many of the long, arrow-straight lines point directly to the rising or setting positions of the sun during the solstices, while others align with the heliacal rising of bright stars like those in the constellation Orion. This celestial connection is undeniable, a clear thread linking the desert floor to the heavens. Yet, in a landscape where rain might not fall for years, a more urgent terrestrial need whispers through the designs. The true genius of the may have been in how they mapped the invisible. Many of the longest lines run straight toward the distant Andean foothills, the source of rare but vital water that flows underground through deep aquifers. Other lines converge on small hills that likely served as ancient ceremonial hubs. This suggests a profound second purpose, a hydrological alignment. They could have functioned as a giant ritual map, charting the subterranean veins of water that sustained life. The lines themselves may have been pilgrimage pathways. During ceremonial times, communities might have walked these sacred tracks in procession, following the alignment toward the mountains to petition the deities believed to control rain and springs. The act of walking the line was a prayer for water, a physical enactment of hope and reverence that tied their survival directly to the landscape's sacred geography. This is where the astronomical and the earthly purposes fuse. The solstice sun, a marker of seasonal change, would have signaled the time for these vital water rituals. The star alignments might have connected those rituals to ancestral spirits or celestial gods. The purpose was not one single thing. It was an interconnected system where astronomy set the calendar, the lines mapped the resource, and the ritual activated the connection between them. And then there are the giant figures, the spider, the hummingbird, the monkey. Visible only from a vantage point no human of that era could achieve, they have fueled theories of messages for gods or even visitors from the stars. A more grounded interpretation, however, sees them as symbolic representations meant for celestial beings looking down. They could be clan totems or mythological symbols offered to the mountain gods or the sky deities, massive prayers drawn in the sand of the desert. The lines challenge us to abandon our search for a single, neat explanation. They are not merely an astronomical observatory, nor just a water map, nor simply a ritual space. They are all these things woven together into a single cultural fabric. The alignment is not just directional, it is multidimensional, connecting the community to the cycles of the sky, the hidden gifts of the earth, and the realm of the divine in one continuous, sacred act of survival. This holistic view forces a pivotal shift in our thinking. If a culture's understanding of the cosmos was this deeply integrated with its practical and spiritual life, how do we, as modern investigators, avoid breaking that unity apart with our specialized, separate sciences? The stones were not the only medium that could carry a message. A fascinating new field of study is now listening to the past, and what it hears is a forgotten dimension of monumental design. This is the investigation of sound properties at ancient sites. It asks a profound question. Did the builders shape stone not just for the eye, but for the ear? In certain places, the evidence is startling. Deep within the hypogeum of On Malta, a 5,000-year-old underground temple complex, lies the oracle chamber. This small, carved room possesses an extraordinary acoustic anomaly. A deep voice spoken into a specific niche resonates throughout the chamber with an eerie, amplified power that seems to come from the walls themselves. This is not a random echo. It is a precise acoustic effect, one that would have transformed a spoken ritual into a visceral, supernatural experience. The sound appears to be channeled and focused by the chamber's shape, suggesting the builders understood something fundamental about how sound waves behave. This principle of designed acoustics appears across the globe. In the pyramids of the Maya, like the Temple of At, a curious phenomenon occurs. If you clap your hands at the base of the grand staircase, the sound bounces back not as a simple echo, but as a chirping tone that closely resembles the call of the sacred Quetzal bird. This sonic mimicry, likely created by the precise spacing and angle of the steps, would have been heard as a direct divine response during ceremonies. Imagine the impact. A priest speaks or chants, and the architecture itself answers, its voice woven into the ritual. This moves the concept of alignment into a sensory realm. If a temple is oriented to catch the first solstice sunrise, and its interior is shaped to resonate with a specific sacred frequency at that exact moment, then the alignment is no longer just visual. It becomes a full bodily experience, synchronizing sight, sound, and ceremony into a single, overwhelming event. Such an environment could induce altered states of awareness, deepening the participants' feeling of connection to the divine. This sophisticated understanding of wave physics points to a holistic science where every element of a sacred space was tuned, from its celestial orientation to its sonic properties. And this leads us to the most intimate scale of alignment of all, the one that begins with our own physical form. The architecture of the cosmos could be mirrored in the architecture of the self. This 13th principle moves the alignment from the distant horizon to the human heart, exploring anthropomorphic alignments, where the temple itself is designed as a map of the human form. In this profound philosophical view, the human body is a microcosm, a miniature reflection of the entire universe, the macrocosm. By building a sacred space that follows the same proportions and orientation as the ideal human form, you create a place where an individual can step inside and literally align their own being with the cosmic order. This transforms the monument from an external observatory into an instrument for internal transformation. One of the clearest expressions of this comes from the ancient Indian science of architecture, Shastra. A traditional Hindu temple is not merely a house for a deity, it is a symbolic body. The innermost sanctum, represents the womb or the heart, the sacred core of consciousness. The towering spire above it, symbolizes the head reaching toward enlightenment. The entire floor plan is often laid out according to a precise geometric diagram, a mandala that maps cosmic regions onto the parts of the body. To walk the prescribed path through the temple is to embark on a spiritual journey along your own axis, moving from the worldly to the divine. This concept traveled across cultures and centuries. In the design of many medieval Christian cathedrals, a similar symbolic anatomy is at work. The floor plan often takes the shape of a cross, but it is also seen as a human figure lying east to west. The altar at the eastern end represents the head of Christ, the place of supreme sacrifice and divine thought. The long nave forms the spine and torso of the congregation, the body of the church. The transepts stretching north and south become the outstretched arms. When enter at the western end and process toward the altar, they are symbolically moving from the feet toward the head, from earthly concerns toward spiritual awakening, aligning their personal journey with the architectural and cosmic narrative of salvation. In both traditions, the orientation is critical. The alignment east-west is not just for the morning sun, it is for the spiritual sunrise within. The building becomes a guide. Its proportions teach harmony, its axis offers a path, and its spaces choreograph a ritual of ray alignment. To participate is to use the architecture to tune your own inner compass, to find your place not just in the city, but in the cosmos itself. This brings our exploration full circle, from vast celestial cycles to the intimate scale of human experience. Yet with all these principles laid out, from solar markers to sonic chambers to symbolic bodies, a practical, modern question remains. How do we, with our tools and our skepticism, actually verify that these ancient feats were intentional? How do we move from seeing patterns to proving purpose? The silent stones now speak through laser light and lines of code. This 14th principle is modern verification, where our most advanced technologies become time machines, allowing us to test the alignment theories of the past with a rigor the original builders could never have imagined. At the forefront is LiDAR, light detection and ranging. Mounted on aircraft, it fires millions of laser pulses toward the ground, penetrating dense jungle canopy to map the terrain beneath with centimeter precision. This technology has revolutionized our view of sites like Angkor Wat and the Maya cities of Central America. It strips away centuries of overgrowth in a digital instant, revealing not just known temples, but entire hidden networks of roads, plazas, and smaller structures. We can now see, for the first time, how a single pyramid was part of a vast, deliberately planned urban grid, its alignments extending far beyond its own walls into the surrounding ceremonial landscape. This gives us the complete picture, the full celestial and terrestrial context in which a monument was meant to function. With the landscape revealed, we then turn our gaze upward, back through time. This is where advanced astronomical software performs its own kind of magic. Programs like can roll back the celestial clock, accounting for a critical factor called axial precession. This is the slow, 26,000-year wobble of Earth's rotational axis, which gradually shifts the position of the north celestial pole and alters the rising points of stars over. A star that was the pole star for the ancient Egyptians is not our pole star today. Without accounting for precession, we would look at a modern sky and completely misunderstand an ancient alignment. This software lets researchers like input the exact coordinates of a site and the precise year of its construction, say 3000 BC, and generate a perfect simulation of the night sky as the builders saw it. They can then take precise measurements from the site, often gathered with robotic total stations that map every angle, and see if a corridor truly pointed to Sirius, or if a window perfectly framed the Pleiades at their heliacal rising. This digital archaeology combines landscape data with celestial simulation to create powerful, three-dimensional models. Researchers can virtually rebuild a monument and then run thousands of statistical tests. They can ask, if we randomly placed 100 temples in this valley, how many would accidentally point to the winter solstice sunrise? If the answer is 2, but we find that 15 real temples from that culture all share that alignment, the evidence moves from coincidence to intention. This rigorous, data-driven approach does two vital things. First, it confirms the genuine, often breathtaking sophistication of ancient sky watchers, lending mathematical weight to their achievements. Second, it acts as a filter, helping to debunk fringe theories or overly romanticized interpretations that cannot withstand statistical scrutiny. It allows us to separate the signal of true knowledge from the noise of random chance. Yet, for all its power, this technological lens has its limits. It can tell us what was aligned, and with astonishing precision. It can even suggest how they might have achieved it, by revealing to distant horizon markers now obscured by forest. But the ultimate why, the lived experience and spiritual meaning of that alignment, remains just outside the scan. The software can show us the solstice sunbeam striking the altar, but it cannot let us feel the collective awe of the community witnessing that moment. This is where technology and tradition must meet. Our satellites and simulations provide the hard evidence, the undeniable fact of the alignment. But to understand its soul, we must still listen to the echoes of myth, study the fragments of ritual, and use our empathy to bridge the gap between measurement and meaning. The mystery persists, not because the data is lacking, but because the fullest truth lives in the space between the measurable angle and the human heart that cherished it. Even with our most powerful tools, some stones remain stubbornly silent. A handful of ancient sites possess alignments so precise, so deliberate, that they clearly signal profound intent, yet their ultimate purpose dances just beyond our grasp. This is the 15th principle, the unsolved puzzles, alignments that defy easy explanation. These are not errors or coincidences. They are the frontiers of modern research, reminding us that the map of ancient knowledge still has blank spaces waiting to be filled. Take the iconic statues of Easter Island. These colossal figures are not haphazardly placed. Many of their platforms, called ahu, are aligned with astonishing accuracy to the cardinal directions east-west. But why? The island's culture left no written records explaining this precise orientation. Was it to face the rising sun, a symbol of life and ancestral power? Or did it relate to an older, lost system of land division and social order? The alignment is undeniable, but the cultural key to its meaning seems to have vanished with the last master navigator. Similarly, the megalithic temples of Malta, like End, present a complex celestial puzzle. While they contain clear solar alignments for the solstices and equinoxes, other architectural features point to stars or to points on the horizon with no obvious solar or lunar significance. Researchers like Frank Ventura have suggested these may align with the heliacal risings of specific bright stars, events that held agricultural or ritual importance now forgotten. The temples seem to be speaking in a multifaceted language where we have only translated a few vital words. Across the Atlantic, at the great city of Cahokia in North America, the mounds tell a story of sophisticated planning. The Grand Central Plaza, flanked by Monk's Mound, is oriented just 5 degrees off true north-south, an alignment that likely held deep ceremonial meaning. The famous, a circle of large posts rebuilt several times, functioned as a solar calendar, marking equinoxes and solstices. Yet, the full cosmological schema that linked these earthworks to the wider landscape and the cycles of the moon remains elusive. We see the individual notes, but we cannot quite hear the complete symphony they were meant to play. These enduring mysteries are not failures of science or history. They are its essential fuel. They remind us that ancient science was not a single, monolithic entity, but a vibrant tapestry of diverse practices and local knowledge. A solution that works for the pyramids of Egypt may not fit the temples of Malta. Each culture looked at the same sky, but asked different questions of it, and built answers that reflected their unique world. These puzzles force a vital humility upon us. They ask us to consider the limits of our own frameworks. We approach these sites with a modern, often Western, scientific mindset that seeks singular, functional explanations. But the builders may have operated within a holistic worldview where an alignment could serve practical, spiritual, social, and political purposes all at once. The fact that we cannot immediately decode a site does not mean it is meaningless. It may mean its meaning is richer and more layered than we have yet imagined. These frontiers keep the field dynamic and alive. They are invitations, not dead ends. Every unsolved alignment is a question posed across centuries, challenging a new generation to look deeper, to think differently, and to perhaps one day find the missing piece that turns a baffling pattern into a clear, profound message from the past. The most profound respect we can offer the past is to believe in its genius. Our 16th principle is a crucial safeguard, the danger of modern projection. In our fascination with these magnificent alignments, a tempting narrative often emerges, one that suggests the builders must have had help from advanced, even extraterrestrial sources. This is the ancient astronaut trap, a form of storytelling that, while captivating, carries a subtle but profound disrespect. It implies that the people of the past, with their own hands and minds, were incapable of such feats. The true scientific and ethical principle is to seek explanations first within the demonstrated capabilities, resources, and cultural context of the people involved. The pyramids are not remarkable because aliens might have built them. They are staggering because human beings, with copper tools and immense social organization, conceived and constructed them. The alignments are not proof of a lost super science from Atlantis. They are evidence of a different kind of science, one built on generations of patient observation, a deep empirical connection to the natural world, and a powerful drive to find meaning in the cosmos. When we project our own technological fantasies onto these sites, we inadvertently erase the very human story of innovation, perseverance, and intellectual triumph that makes them so worthy of our awe. This projection often arises from a modern bias, a belief that precision requires digital tools and that monumental scale requires machinery. We forget the power of cumulative knowledge passed through oral tradition, the acute observational skills honed by a life lived intimately with the sky, and the profound motivation provided by spiritual belief. A society that believed its king would ascend to the stars had every reason to align his tomb with perfect accuracy. A culture whose survival depended on predicting the rainy season would dedicate generations to perfecting a solar calendar in stone. These are not lesser motivations than ours. They are different and often far more powerful drivers of sustained effort. Ethical research, therefore, begins with this respect. It asks, what could these people have known, given what we know about their environment, their tools, and their surviving records? This approach consistently reveals that the solutions were elegantly human. The north-south alignment of the pyramids likely came from patiently tracking circumpolar stars. The solstice markers resulted from centuries of watching the suns crawl along the horizon. The answers are not less magical for being terrestrial, they are more inspiring. They tell a story of our species' innate curiosity and capability. So, what can we, in our age of satellites and quantum physics, possibly learn from this ancient science? Perhaps the most vital lesson is one of perspective. They achieved cosmic precision not by distancing themselves from nature, but by immersing themselves in it. Their greatest instruments were not made of silicon, but of stone, sight, and memory. In our pursuit of ever more complex technology, we might rediscover a profound truth they understood inherently, that the deepest connections are often built not through complexity, but through sustained, reverent attention. Their monuments stand as a testament to a different kind of time. The 17th principle is perhaps the most urgent for us today, a lesson in sustainability and long-term thinking. The builders of these sites did not operate on quarterly reports or election cycles. They thought in generations, in centuries. A project like Stonehenge was not a single construction job. It was a cultural tradition that evolved over more than 1,000 years. This represents a profound, long-term relationship with both the land and the cosmos. They were not extracting from their environment, they were conversing with it, aligning their greatest works with its permanent rhythms. Their science was inherently holistic, weaving together astronomy, ecology, geometry, and community into a single, sustainable practice. In our current age, facing the complex challenges of a changing climate, relearning to observe natural cycles and align our actions with them is not a mystical retreat. It is an essential survival skill, rediscovered in the oldest libraries we have, those made of earth and sky. The ancient principle of alignment teaches us about the power of patient, careful observation. It shows the value of designing human systems that exist in dialogue with their environment, rather than seeking to dominate it. This is the deeper wisdom encoded not just in the angle of a corridor, but in the approach itself. It is a reminder that the most enduring legacies are built by those who plant trees under whose shade they know they will never sit. So how do we, in a world of rapid change and fragile digital records, ensure this hard-won knowledge is preserved for the generations to come? The answer may lie in returning to the methods of the builders themselves, by creating new kinds of monuments for a new age. The stones have endured but their future is now uncertain. The very forces that reveal their secrets, tourism and a changing climate, also threaten their survival. This makes preservation not just a cultural concern, but a scientific and ethical imperative. These sites are not merely beautiful ruins, they are irreplaceable data sets, the original laboratories where ancient science was practiced. To lose them is to lose the primary evidence of an entire branch of human knowledge. This urgent task is being met with tools from our own time. Digital archiving, through meticulous three-dimensional laser scanning and photogrammetry, creates perfect virtual clones of a monument. These digital twins ensure that every angle, every inscription, and every alignment is preserved in exacting detail, a permanent record that can survive even if the physical stone succumbs to erosion or unexpected events. This digital vault becomes a new kind of library, safeguarding the geometry of the past for the analysts of the future. But preservation is more than a technical challenge, it is a deeply human one. This work carries an ethical duty that extends beyond the stones to the living communities for whom these sites are not just history, but heritage. Increasingly, researchers are moving from a model of extraction to one of collaboration. They work directly with descendant communities, the cultural inheritors of the builders, to ensure that investigation respects traditional knowledge, sacred protocols, and local stewardship. This partnership recognizes that the deepest understanding of a monument's meaning may live not in a satellite image, but in an oral tradition. It transforms archaeology from something done to a culture into something done with it, honoring the continuity of memory and identity. This spirit of shared stewardship naturally leads to the vital role of public engagement. When people understand the genuine science and profound cultural significance of these places, they become advocates for their protection. Documentaries and virtual reality experiences can transport anyone to the heart of a pyramid or the center of a stone circle, fostering a global sense of connection and care. Responsible tourism, carefully managed to minimize physical impact, can provide essential funding for conservation while offering transformative educational experiences. Most importantly, by clearly and compellingly sharing the evidence-based discoveries of archaeoastronomy, we provide a powerful antidote to sensationalist myths and misinformation. We replace fantasy with a far more inspiring reality, the story of human ingenuity. This is the ultimate goal, to inspire a new generation of interdisciplinary thinkers. The child who is captivated by the solstice alignment might become the engineer who designs sustainable cities. The student fascinated by the celestial mathematics of the Maya might become the astrophysicist who maps new galaxies. The field teaches that the biggest questions cannot be answered by a single specialty, but require the fusion of astronomy, history, anthropology, and environmental science. The future of unraveling these ancient principles depends entirely on our commitment to protecting the fragile, open-air classrooms where they were first taught. We must safeguard these dialogues in stone, so their lessons can continue to guide us. So let us finally weave all these threads together into a single, coherent vision. This tapestry of intellect stretches across continents and centuries. It shows us a humanity not stumbling in the dark, but actively reading the cosmos, translating its rhythms into stone, and building a dialogue with the universe itself. The solar clocks of Stonehenge, the stellar shafts of the pyramids, the geometric codes of sacred architecture, and the acoustic landscapes of ancient temples, these are not separate curiosities. They are chapters in a single, global story of discovery. Unraveling the scientific principles embedded in these alignments forces a fundamental shift. Our ancestors were not primitive mystics waiting for revelation. They were the original scientists, patient observers who tracked celestial cycles for generations, ingenious engineers who solved monumental problems with simple tools, and profound philosophers who sought to weave human existence into the fabric of a meaningful cosmos. Their goal was harmony, a conscious alignment of community, ceremony, and survival with the grand, predictable order of the heavens. This legacy now challenges us in two profound ways. It asks us to look at the past with far greater respect, to see the silent stones as the pinnacle of their era's technology and thought. And it invites us to look at our own place in the universe with fresh wonder, rekindling a sense of connection that our digital age often obscures. The true alignment we seek today may not be between stone and star, but between their ancient, holistic wisdom and our modern, fragmented curiosity. Their monuments stand as eternal questions. How do we build a legacy that endures? How do we live in balance with the world we observe? If this journey has shifted your perspective on the deep past, we would love to hear your thoughts. Share what resonated most with you in the comments below, and subscribe to continue decoding history's greatest mysteries with us.